Okay, looking at some more application-based questions, some questions that you're definitely more likely to see in an exam. We're first told that a rectangle has a length of 12 centimeters to the nearest centimeter and the width of 4.76 centimeters rounded to the nearest millimeter. And we need to work out the upper bound of the rectangle's perimeter. So first things first, we're going to start off by working out our upper bounds for the length and then the width. So starting with 12 centimeters, let me do this in black. Draw our error interval timeline. So remember that 12 centimeters is going to be smack right in the middle. Then we are told that it's rounded to the nearest centimeter, so we put an additional centimeter on each side of our timeline. Drawing our midpoints in, we have this lower bound to be 11.5 centimeters and our upper bound to be 12.5 centimeters. Now looking at the width, we are told that our 4.76 is rounded to the nearest millimeter. And what I'm going to do is I'm going to put this 4.76 equal to 47.6 centimeters. Sorry, that's going to be millimeters. 47.6 millimeters. And therefore, our upper bound is rounded to the nearest millimeter. What we want to do on either end is add a millimeter on to our original and take 1 millimeter away on the left hand side. So now writing in our midpoints, our lower bound is going to be 47.1 millimeter and our upper bound is going to be 48.1 millimeter. Now we go back to the question. It tells us to work out the upper bound of the rectangle's perimeter. So the perimeter, as we know, is all our sides added together. To get the upper bound of the rectangle's perimeter, we're going to use the upper bound of our length and the upper bound of our width. So therefore, when we fill it in, we're going to convert this back into centimeters just for simplicity's sake. And we're going to do 4.81 plus 4.81 because there's two widths in a rectangle, plus 12.5 and plus 12.5. Adding these up, we've got 2, 16, 26, carry the 2 over, 4 plus 4 is 8, plus 4 is 12, plus the 2 carried on is 14. Let's carry the 1, so we get 1 plus 1. So we get our final rectangle's perimeter to be 34.6 centimeters. Okay, now looking at number 2, we're told a circle has a radius of 7 centimeters to the nearest centimeter. So we draw our 7 centimeters in there. Now that we know it's rounded to the nearest centimeter, we can add a centimeter onto this side and take away a centimeter on this side. We're going to then draw in our midpoints to get 6.5 centimeters and 7.5 centimeters. And now we have to look back at our formula for the area of a circle because we're told to work out the area, right? So the area is pi times by r squared. Now we have to think, it asks us to work out the lower bound, so we're going to use our lower bound value for r. So plugging this in, we get pi times by 6.5 squared, and we can leave this in terms of pi, or we can leave it as a decimal, and in this case I'm going to leave it as a decimal, so we're going to get 132.7 centimeters squared. But you also can leave it in the form of pi if you prefer that. Okay, in this question we're told that a right angle triangle with side A equal to 6.3 centimeters and side B equal to 9.27 centimeters, both rounded to the nearest millimeter, calculate the lower bound for C. Now, if you remember from Pythagoras' theorem. We have a right angle triangle as such. We have A and B as the so-called legs of the triangle, and C is the opposite to the right angle. So A and B can be written in this way, and remember they're completely interchangeable. So we need to work out our C. So in this case, we have to use our Pythagoras' theorem formula to get A squared plus B squared equals to C squared. And remember, this means that C is equal to the square root of A squared plus B squared. Okay, now let's look at our lower bounds for each value. So for A, we have 6.34 centimeters. Now this needs to be first converted to millimeters because we're told that they're both rounded to the nearest millimeter. And this just is going to help us with simplicity. So putting 63.44 smack in the middle. We're told nearest millimeter, so therefore we add one onto the right hand side and take one away for the left hand side. Now, finding our midpoints, we get the lower bound to be 62.9 millimeters and our upper bound to be 63.9 millimeters. But in this case, we're trying to work out the lower bound, right? Therefore, we need this value here. Now, looking at B, we are told B is 9.27 centimeters, which in millimeters is 92.7 millimeters. Drawing our timeline, we put that smack in the middle, add a millimeter onto the right hand side, and take one away on the left hand side. Then, working out our midpoints, we get this one to be let me draw this in red. We get this one to be 92.2 millimeters, and our upper bound is going to be 93.2 millimeters. Remember, once again, we're looking at our lower bound. Okay, now we have our lower bounds, we can work out what our value for C is, or our lower bound for C. So, this is our formula, as we discussed before. So C is equal to the square root of A squared plus B squared. Remember, our lower bound for A was 62.9. We're going to have to square that. And our lower bound for B was 92.2. And we're going to have to square that. Now, putting this into your calculator, you're going to work out that our lower bound for C is equal to 111.63 millimeters. But remember, the question gave its values in terms of centimeters. Therefore, I'd strongly advise you guys to convert back. So, this is going to be equal to 11.163 centimeters. And you can usually round this to 3 significant figures because that's what they did in the question. Okay, that's going to conclude today's video on slightly harder questions for bounds. As always, please make sure to like, comment, and subscribe, and check out the next video for exam style questions on this topic.